Welcome, everyone. Please have a seat, and we'll start the 11:20 session. For this session, we have Ryan and Nicole with us here from Intezer, and they're going to take us into the world of the unknown unknowns and misconfigured devices. I'll leave the word to you. Thank you.
Hello, everybody. Welcome to our session about going with the workflow and how dangerous it could be when you misconfigure a workflow instance. My name is Nicole Fishbein. I'm a security researcher at Intezer, and previous to that, I was in the embedded R&D department in the IDF.
I'm Ryan Robinson. I'm also a researcher with Intezer. In previous roles, I was a security engineer and was securing cloud applications and all. And I was also a researcher in Anomali's threat research team. That's me.
So today we're going to introduce you the world of workflows. We will explain a bit what is a workflow, and we will dive into two case studies of workflows, open-sourced platforms, and how their different features and the misconfiguration of them led to an extensive credential exposure. And we're going to cover some protection methods and tools that you can use to, first of all, verify that your organization is not compromised, and second of all, how to protect your organization. So first of all, what is a workflow? Let's say you have data in a source database, and you want to move it to another database. So you will need to extract it, analyze it, and store it. Each task can be broken into smaller parts. So one task will pipe in the relevant information to the next task. And that's how you create a flow. A workflow platform allows you to create, schedule, and monitor these workflows. And there are different types of workflow platforms. Some cost money, some are free or open sourced. Our research, we focused mainly on open-source workflow platforms. And we wanted to know, can we find instance or servers that has a certain workflow, maybe an exposed dashboard by mistake, without breaking in, without taking advantage of vulnerabilities, just an exposed dashboard. And if we do see something like that, what information can we find there? What type of information is exposed? And lastly, can we execute code simply by having access to a dashboard? So we will start from the first case study.
Thank you very much. So our first case study is Argo Workflows. In my opinion, it's the one with the best logo. So it is. And so a little bit about Argo. It's a container-native workflow engine. What container native sort of means, it means it's the base level of infrastructure. In simple terms, if you can run containers, you can run Argo Workflows. It's open source. We really like open source. It makes it a lot easier for us to conduct research. We don't have to hand over any money and stuff. It also means it's very widely adopted for the most part. You know, people like open source, and it can kind of be a blessing and a curse. If a lot of people are using it, it might also become quite a nice sort of target for people. It's designed for Kubernetes, assembly, and it's incubated by the Cloud Native Computing Foundation, the CNCF. The CNCF are also the maintainers for Kubernetes itself, so Argo is probably as official as you'll get for a workflow engine for Kubernetes. And I'd like to say it's great for compute-intensive jobs with a winky face there. You can probably gather already what you can do with a lot of computing power. So, you know, what is a workflow in Argo? It's defined in YAML. If you don't know what YAML is, just think of JSON, just another markup language, as it's in the name. A workflow will consist of one or more steps, sort of as Nicole was talking about. Typically, these steps are a container. Within Argo, there are a few other types. You can have a script or a Kubernetes resource. There's a few things, but for the most part, it's a container. And very simply, a step you run with an input, you capture the output, and then you'll use that output probably as the input for the next step, and so on, until you complete the task at hand. So this is what a sort of template, a hello world, looks like within Argo. It's just a container, just prints out the hello world. And this is what it's like whenever you submit it through the Argo server. You just submit it like a YAML file, or you can upload something. It's pretty simple, so it is. Another really important concept is called off mode, and there are 3 types of off modes within Argo. There is server, client, and SSO. So the one that we mainly want to focus on is server. And by the time we actually done the research, the default within Argo is server. Since version 3.0, they've made the default the client. And there are sort of reasons behind that for security, as we'll sort of dive into. What the off-mode server looks like is, you'll see the definition there. In hosted mode, use the kube config of the service account. In local mode, use your local kube config. What that sort of means in lay terms, it's if you can access the Argo server, you inherit the permissions that that deployment has been given. So, sorry, I want to go back one for that. I'll use my pointer instead. If you take a look at these verbs on the bottom left, I got this from a quick start YAML file. So basically, if you can reach the server, these are the permissions you get. You see things like create, get, list, watch, update, patch. So usually the quick start, it kind of gives you the full Monty of permissions. So, anyway, so how can this be exploited? I made them spin too many times. So, and I basically boil it down to a simple equation. If you go for server off plus permissions, and if you're allowed to get external access to it, profit. So, what we wanted to do is we wanted to find exposed Argo workflow instances out there. And there's sort of many techniques that you can use. We used internet census tools such as like Shodan, Census, Rapid7 have an open data set. I'll give the link for that later. Honestly, if it's exposed online, sometimes it's even being indexed by the Google spiders, so you can make a simple sort of Google search and you'll be able to find them. You can use the DNSDB. So usually what you can sort of do with that is you can look for subdomains that have Argo in them, maybe sort of argo.company.com, and quite a lot of times they all created a certificate, for their their production Argo server, and you're able to find that way. And also just a classic sort of brute force and permutation. Sort of things to them for is you grab the RSA vendor list and you just put .company.com, just put Argo in front of them and just kind of brute force that. And honestly, you'll be surprised how many that you can actually find. So when we were looking through that, we found something that really interested us. In one particular cluster, we found a Monero miner that had been running for 8 months. So it had, and the Monero miner in question, this Canix Monero miner, it was very, very famous container. Like, it had been downloaded millions of times, so it's used by a lot of people. And actually, the same container, it had been used in wide-scale attacks against Kubernetes clusters, and it had been featured in Microsoft blogs and everything before. So really popular, and it sort of shocked us to find, because initially we were actually looking for something else. We were looking for exposed credentials within the scripts. Something we'll get into more with the second case study, but we found that sort of malware was running on these things. And with that, we sort of found our malware, and now we're going to get into more compromised credentials with Nicole and Airflow.
So the next case study is Airflow. And Airflow is the most popular open-source workflow platform based on stars on GitHub. And it allows you to run your tasks using Python, and it supports many plugins, different sorts of plugins. And the core of Airflow is a directed acyclic graph, similar to what we saw before when you have one task that calls another one. and the basic unit is a task. And there are different structures in Airflow that support your workflow. So for example, if you're writing a task, you're probably going to have some global variables, so you can store them in a dedicated variable structure. Your workflow probably going to connect to different databases and services, so to secure the connection and the credentials, you have a dedicated connection structure. And also there is a logging mechanism in Airflow that supports, that provides you logging information and visibility over the workflows. But as Ryan said, we were able to find lots of credentials all over the exposed dashboards. So we were able to find API keys to AWS, Azure, GCP, PayPal wallet IDs, and so on. And just to make clear, the logos that you're seeing here, we're not saying that these companies are compromised. We mean that we were able to find credentials of users to these services. And the credentials were all over the dashboards, all over the features that we just covered. So let's dive in and see how it looks like in the dashboard. The first place and the most common place where we saw the most of the credentials was actually in the code. Because in the dashboard, you can see the code of each task. And insecure coding practices, when you hard code your passwords and API keys in the code, thinking that no one will see it, but if the dashboard is exposed or the code is uploaded, anyone can see that. One level of abstraction is when you take your credentials and put them in the variable structure. Instead of saving them in the code, you just put it in the structure, and yet it's visible, it's in plain text. The connection structure is the one and correct way in Airflow to store your credentials for connections to different servers and services. And the way to do that is to store the password or the API key in the password field, where it will get encrypted and it will not be visible in plain text. However, many instances that we found, the users just put the information in the extra field, where it's not getting encrypted, and as you can see, it's in plain sight. The logging mechanism in Airflow has a vulnerability that was fixed by Airflow. However, the vulnerable versions had this vulnerability where when you log in using the CLI or input your credentials in the CLI, the data will be stored in plain text in the dashboard, so it's visible. And the same would happen if you use the password field in the connection structure. A configuration file in Airflow is created as soon as you set up your Airflow instance. It's one of the first files that you're probably going to touch. And it contains different settings and configuration. And in previous version of Airflow, it was actually quite long. Many users, they just put the API keys in this file, which could be fine. However, there is a specific flag that when it's set to true, the configuration file is visible in the dashboard. So back to if your dashboard is exposed and your configuration file is exposed, your data is exposed. An ad hoc query allows you to query your databases that are connected to the workflow. And it's a very dangerous feature because leaving aside the fact that the dashboard is exposed, maybe it's not exposed, but there is no verification of permissions or authentication. So basically anyone can access and query the database. And on top of that, if your Airflow instance is exposed, anyone, including the attackers, can steal information using this feature. And now we're left with one question. Can we run malware? And the answer is yes. During our research, we found lots of specific and public images of containers. So an attacker could swap the legitimate image with a malicious image. Once the workflow is executed, the malicious image will be pulled, and malware will be executed. Another way is using the plugins. One of the plugins in Airflow is called Code Editor, which allows you to write your code, Python code, and execute it through the dashboard. So we tested in our own test lab, and we were able to create a crypto mining container using this code editor. And in the bottom line, in Airflow case, we were able to find lots of information that wasn't supposed to be exposed to anyone. And we could say that Airflow is not a very secure platform, but I strongly believe that they do it right. I mean, it's an open source platform, and they improve, they release new versions, they fix the vulnerabilities, they remove the dangerous features. And now it's up to the users to keep updating their versions.
Thank you very much. So those case studies were actually quite spooky. I really laugh when we show those Airflow slides because like 90% of it has to be censored because the amount of passwords and sensitive information, it's what I describe as absurd, absolutely absurd, just what is sitting out there on the open. And very, very big organizations, and the information that you could use, the passwords and all, you could absolutely ruin an organization within seconds. We saw stuff with like payment information and everything. Like you could even steal money from these organizations. It was honestly really, really crazy to see. So I was thinking, okay, how do I protect myself against that? And honestly, you may all know this, but the simple term is just the basics. It's really that simple. So, think about core security concepts. Each of these issues on their own, they might not actually be that bad, but when you chain each one of them together, it can lead to something absolutely catastrophic. So if you take the example, say you have a Airflow instance, and you've misconfigured your firewall or your security group rules within AWS, so that means someone can then access your Airflow instance from the outside, from the wider internet. Okay, problem number one. Then maybe you have an unpatched or a lesser version number of it. It means, okay, there's no authentication to Airflow now, so there's nothing stopping you from just going into the admin dashboard. Go there, okay. Problem number two. Then you get to look at the code or something like that. There's insecure coding practices. There's passwords chucked in there, sensitive information, links to documents. We've seen all sorts, linked to like Google Drive documents. And so say you find some passwords in there, AWS keys perhaps. So you grab some AWS keys. Then those AWS keys, they have too many permissions. You fill in sort of your JSON file within AWS, just star, give them, yeah, whatever you want, God mode, go for it. So then that has too many permissions. You're now admin within AWS. You can sort of draw the rest of the story and think what you can actually do with it. So, again, multiple points along that chain that you really could have stopped something, but sadly, and when sadly we see like hundreds, even in some cases thousands, that many people are doing this. It's just, you can glide through the whole way. So that's why the basics matter. Secure coding practices. Even if you think that someone is not going to see the code, it's just internal, it's just a test. Code is if you assume that someone that maybe you don't want to look at it is going to look at it. So, don't hard code passwords, don't sort of add strings that are going to be executed as commands afterwards. Sort of really think about that, the code that you're putting out. Obviously, patch, update. It's maybe, too many people say it at this point, but it does matter. As you saw for Airflow, there were CVEs that were patched, and so you want those CVEs to be fixed. Vulnerabilities are exploited all the time, and also there are security updates had on that. The people that maintain and develop these projects, they do care about security. They'll add more security features over time in it. So please do patch. Secure configuration. Don't think that just like the most basic configuration that you give is secure. Really do your reading behind and, consider what the configuration of your application looks like to people from the outside. Can they exploit that? And with that, permissions. Follow the principle of least privilege. It's sometimes kind of painful to define, and sometimes you might have arguments with your engineers, but sadly we've seen a lot of times where the convenient thing to do is also the thing that is really going to sting you later on. And with that, a defense in depth strategy, as I sort of said with the chain of issues at the top, sometimes it's inevitable that there are new vulnerabilities all the time. People make mistakes. Engineers are even stressed. Sometimes they've sort of got deadlines, and they'll maybe get stuff done quick, and you kind of have to take account for that. A bit like having backups or ransomware. You've got to plan for the eventuality that some of your layers of defense will fail. So that's why you must have a defense in depth strategy. One thing that I really like to highlight, I'll even point it, the default configuration is not the same as the secure configuration. So if you're using something like, say, kubectl apply quickstart.yaml thing, don't use that in production. Usually the quick start is just something to get you up and running, to really sort of test the waters, of the application that you're using. Understand that it's really not the secure configuration. Again, something that's nice over time, we do see things get kind of more secure, especially with like Kubernetes now. It's actually out of the box. Kubernetes is kind of hard to misconfigure now. The documentation is your friend. Each one of these products that we have shown, there is a dedicated security page for it. Read it. Genuinely, there's some very good information, and it'll explain the concepts within there. So the positive trends, as I've sort of hinted to him, Fiore, many open source projects take security seriously. They're being actively maintained. In the case of Airflow, there are, I think, thousands of contributors. So there's a lot of eyes on it. There's a lot of people using it, and feedback for security gets in these products. They take it seriously. I said there are the dedicated security pages. Genuinely read them. This here talks about permissions and controller security, and really, really helpful information. Helps understand. If you don't understand some of the terminology on the website, it'll help, these sort of things. Also, there are patches released. It might not be the most fun thing to read in the world, sort of change logs and sort of bug fixes, but maybe you could open up something like this to Control F and look for like security. They're pretty open when something is patched for security reasons. And also what's nice is that it's being covered in the media. Whenever a big attack happens against like open source software, whether it be WordPress or Argo Workflows in this case, Airflow, it is covered by the media. So even if you have sort of like your Google News set up, like you'll get these stories straight through your phone, and it's almost like a sort of threat intelligence thing. Like genuinely keep an eye out on the products that you're using, and it'll be in the news. And what's nice is that there are many, many open source tools, many developers. I think it's awesome in tech that there's so much open source and openness about about security, and there are tools to help with that. So a list of my favorite open source tools. I'll not go through every single one of these, but I want to highlight. I really like Git secrets. What Git secrets will do is it will stop you from committing passwords and keys. If you go to commit it, it'll sort of stop you from doing it. Go, hey, do you want to commit that hard-coded password? And maybe not. Cloud Custodian is great. You define sort of security policies in YAML. You can use like cloud functions or things like AWS Lambda, and you can sort of run that defined policy violations within your cloud environment. And I like Magpie as well. I've had sort of CISOs come to me and go, Ryan, what are we running that's exposed to the wider internet? So, oh, I don't even know what we have. That'll help you basically do asset discovery and figure out, how can you sort of defend something if you don't even know if it exists. And sort of with that, these are the QR codes to the blogs, one for Airflow, one for Argo. Really, really interesting. Please take a look at it, and thank you very much. Do you have any questions?
All right. Thank you so much. As there are no questions, I'm sure that everything is crystal clear.
Yeah.
So Ryan will be with us for the next talk as well, and I'm sure you also can talk to them after the presentation if there are anything else you'd like to ask about. This is a sensitive matter, so might not everybody want to ask him for an open mic, and I'm sure some of us are going to go back and check our configurations now. With that said, thank you very much to Intezer and Ryan and Nicole, and we'll have a short break and be back soon.
Thank you very much.
Thank you.